Hello everyone. In this video, I'm going to do electricity module 9. Module 9 has 3 subheadings or topics: electricity or electric circuit components and Ohm's law. So today I will do electric circuit and Ohm's law only. Important terms: you must be able to define current. Electric current is defined as the movement of electric charges in a specific direction through a material or through a conductor. It is measured in amperes. So at the end of your calculation, you just put capital letter A as a unit symbol. Potential difference. The symbol used to calculate potential difference is V. It is that which causes current to flow between 2 points in a conductor. It is measured in volts. Symbol to calculate potential difference is V, and the SI unit symbol is also V. A volt, which is the SI unit of a potential difference. It is the potential difference that will cause 1 ampere to flow through a resistance of 1 ohm. It is also the SI unit of a potential difference. A resistance, a symbol that is used to calculate resistance, is capital letter R. Resistance is defined as the opposition offered to the flow of electrical current. And the SI unit of a resistance is ohm. So the symbol, you will see the symbol on the next slide. Ohm's law. The magnitude of electric current is directly proportional to the voltage and inversely proportional to the resistance, while the temperature remains constant. Conductors and insulators. A conductor is a substance through which an electric current can flow easily. Examples of conductors are silver, and it is the best conductor. Copper is the most commonly used, iron, steel, aluminum, brass, and carbon. But an insulator is defined as a substance that offers a very high resistance against the movement of current. Examples of insulators are mica, asbestos, ebonite, rubber, porcelain, and plastic. Resistors that are connected in series. The components of electric circuit. A circuit consists of a resistance. It consists of a conductor, the wire that you see. It consists of a cell. It also consists of a battery. It consists of an ammeter, an instrument that is used to measure the electric current through the circuit. It also consists of a voltmeter, an instrument that is used to measure the potential difference or a voltage. So the calculation will be based on circuits that are connected in series, circuits that are connected in parallel, and the combination of the two. On the left-hand side, the resistors are connected in series. On the right-hand side, the resistors are connected in parallel to the cell. The cell is the cell that we call a battery. It is called a cell. But when you see more than one, it's called a battery. This diagram is a series connection, and the second one is a parallel. So on a parallel connection, a current flows from the battery through the first resistor. Then a current will have nowhere to go but transfer to the second one. The same current flow through the last one, then back to the source. So on a series connection, current is the same. When resistors are connected in series, or even if it's valve, electrical components, they have a resistance. So this can be the valves. If they are connected in series, the current will be the same. There is the formula for a series circuit. I1 is equal to I2 equal to I3, depending how many components that are connected in series. But on the parallel side, we consider current even on the parallel side. The current will flow from the battery. When it gets to this point, it branches. So in series, the behavior of the current is the same, but in parallel, the behavior of the current, it branches. So since the current branches, the total current will now be divided into I1, I2, and I3. So the formula for parallel connection when it comes to current, it will be IP, which is current on the parallel section, will be equal to I1 plus I2 up to the number of resistors that are connected in parallel. So you add, but on the series, it is the same. The resistance, if these resistors are 3 ohm each, so the total resistance will be 3 plus 3 plus 3, which is 9. And for the series connection, when you calculate the total resistance, you plus. It will be R1 plus R2 plus R3. If there are 5 resistors in series, it will be up to plus R5. So you add the resistors. But if the resistors are connected in parallel, 1 over Rp is not the total parallel resistor, but it's 1 over Rp equal to 1 over R1 plus 1 over R2 plus 1 over R, depending how many resistors are connected in parallel. Now, to get the Rp, you must get the inverse. Inverse of 1 over Rp is Rp. So you also do inverse on this side and you do the inverse on the answer this side. Alternatively, when you calculate the R parallel, you can simply do it like this. If there are 3 resistors that are connected in parallel, to get the Rp, you just write Rp equal to 1 over R1 plus 1 over R2, depending how many that are parallel, but to put bracket and do the inverse, because the inverse of 1 over Rp will be Rp. So you write Rp this side, and this answer of this side, you do the inverse. So a calculator has this button of the inverse. You just punch in everything, close brackets, and put that to the power -1, the inverse button, to get the parallel resistor. Sometimes you find that if resistors that are connected in parallel, there are 2. Let's say one resistor is 4 ohm and the other resistor is 1 over 3. So it's easy to do it like this. Rp is 3 times 4 divided by 3 plus 4. But if there are 3 resistors that are parallel, this formula doesn't work. You have to use this one. A voltage on a series connection. If this battery is 9 volts, these 9 volts will be given by V1 plus V2 plus V3 if the potential difference is 9 volts. So when you calculate the voltage or the potential difference, you add in order to get the total on the series connection. There is a formula Vs, which is all the resistors that are series. So their voltage will be given by the sum. But when the voltage are connected, or resistors are connected in parallel, voltage will be the same. So voltage across a parallel connection is the same. If the supply voltage gives 9 volts, these 9 volts connected from here and connected from here will give you the same reading across these resistors. So each resistor will be 9999. Parallel resistor, the voltage is the same. Series resistors, you add to get the total. Now, a question can be, when we have the bulbs that are connected in series and the bulbs on the right-hand side that are connected with LED that are connected in parallel. Let's say this was an LED, LED, LED. So the question can be which set or which one will have more brightness. Let's assume each is 3, 3, 3. So the total voltage resistance will be 9. And the supply is also 9 volts. This side, if there are also 3, the total resistance won't be 9 because it will be 1 over 3, 1 over 3, 1 over 3. It will give you less resistance. So when the resistance is less, it means there will be more current flowing. So the parallel resistors or parallel bulbs that are connected in parallel will have more brightness compared to the bulbs that are connected in series. In series, the resistance, let me show you an example. When we have 3 bulbs that are connected in parallel and 3 bulbs that are connected in series. So each resistor is equal to 3 ohm. If they are series, R series will be equal to R1 plus R2 plus R3. 3 plus 3 plus 3 equal to 9 ohms. But if they are parallel, RP will be equal to 1 over R1 plus 1 over R2 plus 1 over R3, all to the power -1, which is the inverse of the parallel resistors. So this will be 1 over 3 plus 1 over 3 plus 1 over 3, all to the power -1, which is the inverse. Then you use your calculator to just insert as it is. You open brackets, 1 divided by 3 plus 1 divided by 3 plus 1 divided by 3. Close brackets, all to the power -1. And the answer is is 1. So the answer is 1 ohm. So when resistors are connected in series, there is more resistance. And when resistors are connected in parallel, there is less resistance. Remember, a resistance, it resists the flow of current. So there will be less current here, but there will be more current. So there will be more glow when globes are in parallel, and there is less glow when bulbs are connected in series. Another question can be, if one of the bulbs is removed, so if we remove a bulb that is here, this circuit will be broken, so there will be no brightness. There will be no flow this side. But if we remove one this side, current will still flow to the other bulb. So in series connection, there will be no bulb. In parallel connection, there will be a glow. Even if you remove one, or you remove two, or you remove three, there will be glow. Okay, let's look at the activity. An example. First, look at the formulas. The formula for series will be given. The formula for parallel is given as 1 over R, 1 over R. All you need to remember is to do the inverse. So you can keep this side as RP because you don't calculate 1 over R, you calculate RP. But this side you put brackets all to the power negative 1. Let's do this activity. It says 2 bulbs. Choose the answer, write only A or D next to the question number. 2 bulbs A and B are connected in parallel and then connected to the supply voltage of a simple D circuit. They are parallel. What will happen with the brightness of the bulb when brightness of bulb A when bulb B blows? The brightness will stay the same. It will stay the same. Number 2, when 2 resistors of different magnitude are connected in series, the current passing through the bigger resistance would be, remember they are connected in series. So in series connection, current is the same. Current is the same. 9.3. When you answer the question, when you are given the word statement, you must first sketch that circuit. You sketch the circuit so that you can, to sketch it, it simplifies the problem. A DC circuit has supply voltage of 18. So 18 is the supply, which is the voltage across the terminals. It is 18 volts. Resistor R1, 8 ohm, is connected next to the supply. This is 8 ohms and is R1 next to the supply. Is connected next to the supply in series with 2 resistors that are connected in parallel. So this resistor is in series with the other 2 resistors that are connected in parallel. It's R2 and R3. And R3 of 6 ohm. First question says, calculate the equivalent resistance of the parallel section. Let's look at the solution. Parallel is 12 and 6. And 6 are in parallel. So RP is equal to 1 over R2 plus 1 over R3. It's R2 and R3 that are parallel, all to the power negative 1. This is equal to 1 over 12 plus 1 over 6, all to the power negative 1. And this side you have RP. So you just use your calculator, you insert this as it is. Once you insert it, so in some questions, you can be asked to calculate one of these parallel resistors and will be given the total resistance, which means this side can be given. When they give you RP, they don't give you 1 over RP, but they give you RP. Now, if one of the resistors is given, you're going to put it as 1 over given resistor. The unknown would be 1 over R3 if it's unknown. Then to remove the inverse from this side, it comes to this side. It will come to this side and you solve for the unknown. So you do the inverse of this exponent and take it to this side. The answer of these parallel resistors will be 4 ohms. Second question says calculate the total current flowing through the circuit. Total current flowing through the circuit. So when you calculate the total current, we use Ohm's law. Ohm's law says the current is directly proportional to the voltage and inversely proportional to the resistance. So this is voltage total, or it's called the EMF, that force that causes current to flow between 2 points. And this is the total resistance. So we only calculated parallel section. So this circuit, when this one is eliminated, it will become like this. This is 4 ohm. And this side you have 8 ohms, 4 ohms, which is RP. Now we can calculate the total, they are series now. So the RT will be equal to R parallel, which is this 4, plus R1, the 8 is R1. So 4 plus 8 will be equal to 12 ohms. Then we can calculate the I total. IT will be equal to V or EMF divided by R total. Where there is voltage, it was given as 18 volts. So it's 18 divided by 12. Use your calculator to get what is the current. 18 divided by 12 is 1,5. So this is 1,5 amps. Question number 3. A voltage drop across the 8 ohm resistor. You are looking for the voltage across the 8 ohm resistor. We use Ohm's law to calculate that voltage across the 8 ohm resistor. For number 3, Ohm's law says I equal to V over R. The current from the battery, it branches here, but what entering the junction leaves the junction. Then it goes through this 8 ohm. Current from the battery, it branches here. So it enters the junction, but leaves the junction as the same as when it enters. Then it flows through the 8 ohm. So total current is the same current that flows through the 8 ohm. So when there is current, we're gonna put 1,5 equal to the voltage is what we want there, divided by R is 8. It says through the 8 ohm, so resistance is 8. So these two, they multiply. V will be equal to 8 times 1,5. And this voltage will be 8 times 1,5 is 12. Is 12 volts. We got the voltage as 12 volts. The last question says, calculate the current flowing through the 12 ohm resistor, so which is the one that is parallel. Okay, Let's get that current flowing through the 12 ohm resistor. Number 4. The current flowing through the 12 ohm resistor. In order to get current through that resistor, we're going to use a formula of I equal to V over R. But this voltage is that of parallel and this voltage is that of 12. The relationship is that when resistors are in parallel, they have the same voltage. So we can first get the total voltage of this circuit, the one we're going to call VP. As you can see from Ohm's law, when you make V the subject, it becomes IR. So we're going to call it VP for parallel. It will be equal to current that's flowing through, which is total current of that section, multiplied by total resistance of that section. So total current is 1,5. This 1,5 will split into these two resistors. So it's total of this section. And the total resistance, we got it is 4. So it's 1,5 multiplied by 4 equal to, this will give us 6. So the voltage is 6 volts. Remember, the voltage that is supplied to this circuit must be equal to the EMF because not everything is in parallel. So the voltage across the parallel is the same, is 6 volts. And the voltage across the 8, we got it as 12. So 12 plus 6 is equal to 18. So we got that total. Now we can calculate the current across the 12 ohm. I will be equal to V over R. 12 was R2. Voltage is the same, is 6 divided by 12. And this will be 0,5 amps. We can also calculate current across, it's not part of the question, but I'll just answer. The current across the 6 ohm resistor. Voltage is the same. So voltage is 6, which is V. We got the voltage across the parallel is 6. Divided by, this R is also equal to 6, this one. So it's 6 divided by 6, which is equal to 1 amps. Remember, we said the current branches here. So it branches, and through the 6, the current that goes to that 6 is 1 amp. And the current that goes into this resistance of 12 is 0,5 amps. So total current is 1,5. When you add 1 and 0,5, you get 1,5. You see, the bigger the resistance, if it's 12, there is less current. And if it's 6, it doubles. 6 is half of 12. So also the current is double of that. I hope you understand. Thank you.